So, welcome to another episode of Beta Talk. This season is being sponsored by Primary Pro, which is a great initiative started up by my friend Dave Smith. It's an outdoor pipe lagging system, pipe insulation system for heat pumps. So, check them out on the website. It's called Primary Pro. A lot of the good engineers I know are using it. So today we're talking to Katrina Young from Energy Systems Catapult. We're going to be talking about the Electrification of Heat project, which some of my listeners will know lots about already. And we've also got Trysten on the show. My regular listeners know who Trysten is. He's been on the show a couple of times, and he runs the thing called Open Energy Monitor, where they're monitoring heat pumps around the country. And of course, the Electrification Heat project was all about, well, it wasn't just about monitoring heat pumps, but that was a big part of it. And so I suppose the first thing, Katrina, welcome to the show. You've not been on it before. Uh, Give us a little synopsis about the Electrification of Heat project in case people don't know what it is.
Yeah, thanks, Nathan, for having me. So, in a pre-COVID world, 2019, government were facing a lot of questions and pressure about the potential role of different heating sources in decarbonizing the UK heating systems. And the big question is, what's the role of hydrogen and the role of heat pumps? And I think we're probably on this call a similar view of what the role of hydrogen should and should not be in terms of homes. I don't think it should be and potentially accept in some interesting applications around localized industry clusters. But for and I know that we know the industry knows how well heat pumps can work and have done for a long time. But for the government to make kind of evidence-based policy, which is what we hope for, if they say no to hydrogen, they're effectively saying yes to heat pumps and heat networks at a major scale. So they need to know answers to a lot of questions or the consequences of that decision. And as the saying goes, the plural of anecdotes isn't data. So they needed the kind of systematic, wide scale trial of getting that evidence base for the feasibility of rolling out heat pumps at scale across the UK. So that's kind of the background for the Electrification of Heat demonstration project, and that was the thinking behind it. So it started in 2019, and we went out for a commercial tender, and so we bid as part of a consortium. And it was delivered during COVID, which made some challenging installation timescales and supply chains. And we finished monitoring heat pumps at the end of 2023. And so last year we finished all the analysis and publication of the final reports for that.
Have you been, because obviously I know Energy Systems Catapult quite well, quite large teams now. Have you been part of this, or have you been working on other stuff, or is this been sort of your main thing that you've been working on for the last few years?
No, this is so I joined the Catapult about 2 years ago. So I came in kind of midway through the project. So I'm practice manager for heat and local energy policy in the policy team. So I cover quite a wide range of things, so heat policy, and then also our local area and energy planning aspects. So there was a big team in the Catapult, and of course the consortium working on it.
Where were you before, Katrina?
I was a climate change consultant, so I was working on greenhouse gas emissions inventories and policy, and the private sector and public sector.
And you mentioned a quote there that I actually haven't. Plural of, what was it? The plural of anecdotes. I've tried to write it
The
down.
plural of anecdote isn't data. Yeah, I like the saying because there's a lot
Wow.
of like the known. You talk about it a lot in terms of the known unknown unknowns and known knowns and things, and it's really part of making policy is having that rigorous like tested evidence base that to make these really big questions on the future of society and the future of the country and how it looks, and to have that evidence that isn't just anecdotes of that works great or now that doesn't work, I think is really important.
Yeah, and and I've got to hold my hands up here because obviously it's very easy for me to say things like I suppose one of the so obviously Energy Systems Catapult have been writing reports throughout the project, and I think the first report was mainly around most archetypes of home can have a heat pump, and obviously there's evidence of that now. Now, obviously, me being me, and I'm wrong with this because you do need evidence. But I would say that we know that because the laws of thermodynamics dictate
Mm.
that. Do we need a study to tell us that? Because literally the laws of thermodynamics do dictate that. However, I'm wrong because you do need some sort of evidence to sort of help others on sort of the whole. I mean, interesting. You've mentioned hydrogen. I mean, the biggest sort of proponents of hydrogen, I suppose, uh, who should be quite objective, because I'm going to mention them because I'm independent, I can. The Heating and Hot Water Industry Council, who should be about all heating technologies, have seemed to have gone down this hydrogen path and completely forgotten about heat pumps, considering heat pumps have been heating buildings before we had natural gas boilers in this country. Um, but one of the things I want to be discussing in this episode is what the HHIC have been doing is using the data that's been collected from this project as evidence that heat pumps aren't that good. So I've heard people from the HHIC, at senior leadership level, use the average mean specific seasonal performance factor as evidence that they aren't that great. And I think that's been challenging for me personally because obviously I'm out there as a big advocate saying, well, of course this technology is okay and good, and you got people on that sort of side, especially the hydrogen sort of camp, saying, well, no, because this latest study has given, what was it, Tristan? You will know better than anyone because you sort of analysed it's 2.8, isn't it, for air source heat pumps? Have I got that right? 2.8
Yeah,
seasonal performance
yeah,
factor,
2.8.
um, which is actually the MCS limit, isn't it? Um, and then if you drill down into the data, which obviously Tristan has, I mean, that's another thing. The latest energy systems catapult did say in the summary and the conclusions, and the majority of heat pumps operated with good efficiency. Well, they didn't, and I think that's you know the people, the naysayers, are using that as animation and against us, which is a bit of a shame. But I mean, the actual study is great. I mean, I know Tristan, there's some lovely positive stuff to come out of it, and you've been able to sort of do your geeky data thing and do all sorts of things. Uh, and I'm dyslexic. I'm not that great at looking at data or tables, but even I've been able to sort of go. There was 19 installation companies, so I've been going through them over the last couple of days to see how well these installation companies did with their installations. Not that good, a lot of them, if I'm honest. I mean, coming back to you, Katrina, there was three partners that covered the whole of the UK. So if you just talk about them and what sort of areas in the UK they were covering, OVO was one of them, wasn't it?
Yeah, so OVO had three, main delivery contractors. OVO focused on the southeast, so outside of London, but southeast. We had Eon focused around the northeast, so around more urban areas around Newcastle. And then Warmworks was the third, and they were in Scotland. So it's three quite different geographic areas, like climatically as well.
Yeah.
And they had different methods of recruiting participants. So some focused on their current customers, and some it was also much more mixed of like social media, word of mouth, traditional communications, and recruitment. And the messaging for the recruitment was very much on the low carbon side of making of decarbonizing your heating system, and secondly, getting a free heat pump. So that's what it was. Um, no part of the messaging was about bills and energy savings and bill savings because we couldn't promise that. We didn't know what that would look like, and we had a really encouraging recruitment process of the numbers of people applying, and we ended up installing 742 heat pumps across those three areas. Mostly air source, a few ground source, and about a fifth were hybrid heat pump systems.
Yeah, I think was it Eon mainly did the hybrid systems, I think, wasn't it?
Yeah, that was the hybrids were interesting because so Eon told us that quite a lot of their customers were interested in hybrids from in hybrid heat pump systems from the perspective of that it felt less risky for them to keep their gas boiler, but also make that step to decarbonisation of getting a heat pump as well. Whereas actually OVO told us that their customers were less interested in the hybrid system because they wanted to go the full decarbonisation step and saw it
Mm.
kind of just as a stepping stone. And I think the hybrid heat pumps, I know we've talked about it before, but it is an interesting proposition of because you do have both of those sides, and I think it's yeah, a really interesting customer proposition. But there's certainly benefits to the energy system of having them. But how wide scale we'll see them rolled out will be interesting.
Yeah, I really like this because I think the data around the hybrids is really interesting, and it's a lot of people are going to be able to dig into it because obviously, there are a couple of manufacturers I know in the Heat Pump Association that are really pushing hybrids. I had an excellent podcast guest on here, Christoph, who frames hybrids really positively because it's a system. They're kind of doing things like that in the Netherlands around hybrids, and it's very helpful for the homeowner because it's a little step, and he frames it much better than me. However, on this particular project, hybrids come out the worst. I mean, I think Tristan, you'll know that. I think they come out once you've corrected it because you had to correct some of the data, didn't you? And I think they're about 2.7 roundabout.
2.5, I think. I think that's fairly consistent with the original result.
Right. Now that's arguably not that good. Um,
It'd be
uh,
interesting. It might be interesting to hear from Katrina, what the energy system catapult's view on the overall result, and before we sort of dive into it, maybe.
Yeah, and to pick back up on the point you made earlier, Nathan, about some players in the industry citing it as evidence that heat pumps aren't any good, not performing well. And I think I'd want to distinguish between the efficiency and the performance. So yes, we know heat pumps can and ideally should be operating with COPs more than three, more than four, um, and have that really high efficiency. But from a performance perspective, I would also include in that definition how warm the people are in the homes and the general satisfaction levels with the project were pretty good. So we had 85% of participants would recommend the heat pump to their friends and family. And so that we think is a success. That was one of the key goals of the project was to test the customer acceptance
yeah,
and awareness of heat pumps, as well as the kind of can you put heat pumps in all these different archetypes of houses that we have in the UK.
yeah.
And so I think that's done really well. And I think there's lots we can learn from the project, lots we have learned, and things that have led to or leading to policy changes because of the project and what we've learned from it. But it's the different the how people use the heat pumps and live with them and how they keep make themselves warm with it doesn't necessarily mean they'll get the highest COP. And for me, obviously, we want to, have a high COP efficiency to have lower electricity demand on the grid and everything, and lower bills. But it's not the be all and end all of this. If we can get people happy with heat pumps at these COPs, then I think that's a success.
Well, it's an interesting point. So I've got to push back a little bit on this.
Yeah, do you go for
So
it?
so everyone who had one of these installs had it for free.
Hmm.
So arguably they are going to be a little bit more content than someone that's paid for it and they aren't, and their bills are higher. So most of the people in this study, I would say, their bills are actually higher than what they would have been on gas because you have to have around about 3.3 SPF to have cost parity, and there's a lot on this that haven't got that. Now there's five homes that had heat pump systems installed that were over £40,000. They got them free. So the ones that had ground source heat pumps, I think there's five that are over 40. The top one was about 48,000. If I'd had a £48,000 install, I probably wouldn't be that worried if it was a cop or two. I'm thinking, nice, when I sell my house, I can sell it with a top, well, it's not a top-notch ground source because it's not performing as well as it should do. I mean, this is one of the interesting things I picked up, the ground source heat pumps and the ground source industry have always had this, and I, yeah, I like the ground source heat pump industry. I speak at their events, etc., and I'll speak at their next one. But there's always been this tension between the air source heat pump manufacturers and the ground source heat pump manufacturers about who's who and who's the best performing. And Arguably, ground source heat pumps should perform a little bit better because you've got a constant source temperature, roughly. But
Mm.
that can be their downfall as well, because if we have a really good mild winter, the ambient air temperature is often above what the average ground temperature is. But yeah, the ground source heat pumps didn't perform as good as well as they should have done. And I mean, Kenza had 6 or 7 units. Theirs all performed under what MCS require. 2.8 is what MCS require. I think their highest Kenza performing one was 2.75 and the lowest was 2.36. So that's arguably under MCS guidelines of 2.8. So the interesting thing for me is, why were them ground sources? So going back to the customer satisfaction, yes, if you've had a free heat pump install, you're probably more inclined than an ordinary customer to say, yeah, we're happy with it. Um, I mean, I have spoken to some customers and on the project, and generally it was positive, but they realised there were some problems. I'm also under NDA because one of the three partners realised there were some problems with installation and got hold of me to see if I could help them. I won't mention them because, like I say, I can never remember what I'm allowed to say and what I can't say. But it was realised quite early on, because obviously the monitoring started quite early on, that some of these systems were performing very poorly. They then had an auditing process. So I know the auditor, and I would argue that auditing process wasn't that great. Now, that's just my personal opinion. I've got I've got lots of experience and qualification to have that personal opinion, but I'm not going to dive into that any further. So yes, it was good that people felt positive about this, and it's good that that continues that sort of discourse. So I've recently been speaking to Oxfordshire Council, who've had a sort of an open day thing with some of the things they did on heat pump project. I've also just interviewed Katrina from Nesta, and obviously they've got their visit a heat pump system. So this whole thing of social proof, where people are talking positively about it, is a good thing. So that is a good thing from it. I think the main thing is, I still, because I'm constantly talking about this technology. I constantly get barraged by people going on about hydrogen. Yeah, but look at that study, Nathan. Look at that study, Nathan. Look at that study, because they're going to be drilling down. I mean, Trysten has done some amazing things with the data, but I said to him the other day, I said, crikey, the naysayers are going to be really digging into your data now, because you can look at, there's 19 installers, and arguably they aren't doing great. Now, I use this term, don't I? Unconscious incompetence. It doesn't mean they do it on purpose. It just might mean there's some things that they just don't know that we can help them know, and we can move on. Because fundamentally, the Energy Systems Catapult report does say at the end, the majority of heat pumps. And I want to pick up on a point as well there. Yes, people are warm, but that is a different thing to efficiency and performance. So
Yeah,
it's not
agreed.
hard. It's not hard to put a heat system in to keep people warm. All right, trust me. But you can do that with a very poor efficient system. So the two are different. Now the homeowner does want to be kept warm. Most of them won't be bothered about SCOPs and SPFs, H4, boundary H4s and boundary H4s. They want to be kept warm. They will be bothered if their bills are high. And I get a lot of customers ring me up about their bills. Uh, I seem to be this complaint sort of wall for lots of people. But so yeah, I understand why some people on this project would have been positive about it. It'll be interesting to me, because some of these bills will be quite high for some of these people looking at their performance. I mean, Tristan, what was the main thing you got from the data? Because obviously, great data. I mean, that is one of the. I mean, some of the data points that was being collected. I mean, I don't know who did that bit. I don't know if that was LCP Delta or there was something Oxford Computer something, wasn't there?
Also computer consultants as well. Yeah.
You're Oxbridge, aren't you, Katrina?
I live in Oxford, yeah.
Did you do your degree there though?
I did my undergrad at Oxford, yeah.
Yeah, brilliant. Yes, so Tristan, what did you, when you come across this data, what was the stuff that sort of really pinged out to you?
Well, yeah, thanks. I guess I'll just start and say what we've done. So, first of all, big thank you to the Electrification of Heat team for making the data available. So there's a lot of work that goes into preparing all that data, making it easy to download. And so I've always been kind of interested to understand why these large studies kept coming out with relatively low performance figures. So, this isn't, there's been 3 or 4 large studies over the years, starting with the energy saving trust study, which had the average performance of air source heat pumps at 2.45. And that performance has been increasing slowly. So we're now at 2.8. But we'd always seen, looking at some installs by John Cantor early on, we were seeing average performance higher closer to 4. And so it was always a question in my mind, why are we seeing this difference? Where's this gap coming from? And so first, thanks to Electrification of Heat team for making data available. What we've done is basically just download that data and upload it onto our platform. So you normally go to heatpumpmonitor.org to see the heat pump monitor project systems that are being monitored. This website is just a slight variation on that. It's got eoh.heatpumpmonitor.org. So if you go to that, you'll see all the systems that have been monitored as part of this project. There's a big table. I think there's about 500 systems on the first page, and about, I think, 170 on the sort of non-exclude on the excluded list. But you can explore that in as much detail as you want. And from my perspective, the first goal of what I was trying to do there is just make that data available, make it possible for your listeners, engineers, installers, householders to go and look at that real data, zoom in on a particular system, see what's happening. Because when you look at a number in a report, it's hard to understand where it comes from. But when you actually go to that website, click on a system, zoom into a particular day, look at what it's doing on the 7th of February of whichever year, and you can really see what's happening, and what is the kind of system, what's the kind of running pattern that delivers the performance that we're seeing. Obviously, there's a big wide range of performance in the study, so you've got some really great systems, and then you've got this kind of average. You've got a very wide middle where you've got a lot of systems around 2.8, and then you've got quite a lot of systems on the low end as well. So you can, that's the first thing. Obviously, there is a very large number of systems on the study. So, and I was doing this my part in my own time as a side project. So to painstakingly go through every single one of those systems and characterize what's happening is not something I've been able to do just yet. I've done some kind of overall analysis that is possible to do. So you can sort of automatically calculate, what kind of a few key parameters to kind of get a kind of big picture view. But what I have done is drilled in on, I've probably gone through several hundred, but I've maybe in more detail looked at that number of heat pumps, and you just notice particular things about how they're running, I guess. And we've created there's a thread on the Open Energy Monitor forum looking at the data, and I'd encourage anyone to have a look through that thread. We've got a bit of commentary discussion, and there's some of the participants on the project are also involved, and they've shared their experience. So there's been already some really interesting learning on that. So, I mean, the one thing that does stand out to me was, to start with, I was really surprised just how many valents were on the system that were not performing as we had seen on our own on the heat pump monitor project. So, we're very used to seeing valent hitting top end performance. They are installed in large numbers by HeatGeek installers, and they're getting really good results. I mean, that's the thing about heat pump monitors. You've got that, thanks to some really good installers that have been installing systems using our monitoring kit, and also the householders are really engaged. So you've got this kind of combination, this collaboration between householders and the installers, and you're getting some really good results on there. Um, but yeah, it was just you could see quite a few valents that on the electrification of heat trial where it was obvious that the weather compensation curve was left really high. The heat pump would come on, it would ramp up to 50 degrees really quickly, hit the room temperature sort of cut out on the valent controller, and then the heat pump would go off for an hour and a half, start up again. And, if Adam at HeatGeek's done some great videos on how to optimize the valent controls and how to set the weather comp, how to not rely on that like sort of on-off thermostat cut off, but to rely on the weather comp curve. And if you do that, you can bring those average flow temperatures right down and get a really good, much better performance. So I think, that was one of the things that really stood out for me. And I haven't been able to go through all the systems and say statistically that occurs this percentage of time. But it definitely did seem to come up quite a lot. So I think that's
Which is simple
If
to
I'm
rectify, isn't it? Actually, it's a control thing, isn't it?
yeah, that's the positive thing, isn't it? Like
Yeah,
potentially that's a relatively
yeah.
inexpensive thing to sort out. And a lot of the systems installed had radiator upgrades, good equipment were put in. So there's a lot of things that have gone right. And it'd be a shame for it to, well, I guess the question is how much of that difference between what we're seeing? So on the kind of 47 systems that we've got H4 boundary seasonal performance factors for, we're seeing an average SPF of 4. The average SPF on the electrification of heat trial so far is 2.8. So there's this gap. Question is, what are the main reasons for that gap? And what can we do, as an industry to move the average, to raise the bar, move the average performance up?
hmm.
We're probably not going to get to 4 as an average, but if we could get to like 3.3 or 3.5, that would be a huge step forwards.
Yeah, if I'm allowed to come in for a minute, I'd like to, I guess, come back to a few things that you said. So the goal of this project and of this demonstration trial was not to get them at the best cop that we could. That wasn't part of it. Obviously, we want them to be performing well, but that wasn't kind of baked into it. And the 42, is it 442 that you had on Open Heat Pump Monitor? As you said, they like really engaged customers as well. And that's, in my mind, that's not, we can't be wanting everyone in the UK to be really engaged with their heating system and their heat pump when they get it. That's not going to go well for national rollout. So part of the trial is to see kind of the state of the industry at the time. So this is almost like 4 years ago now when they were designed and installed. And so it's seeing what the kind of business as usual was for the industry for heat pumps. And yeah, I think we've learnt a lot. I think there's a lot that was raised, and as you said, there were lots of um, small issues identified very early on because of that monitoring. And the monitoring, I think we're all in agreement here for that of how important the monitoring of these systems are. Like personally, I'd like to see monitoring, like third-party monitoring for all installs under government-funded schemes like the boiler upgrade scheme. I think that would allow much better identification support systems of those. That into that monitoring, we could then go back to the properties and through the QA process. So we had Tech doing that QA, and they were able to identify lots of sometimes a lot of small issues. Common ones were there was a common one about paperwork and electronic documentations going to people's spam folder in their inbox and so not being like explained how to some sort of controls. Common ones are about installation of pipework, so like external or in the loft. And one thing they raised was about the clearance of components, so from like the base unit to the ground, and it was raised at installers, so the installers would benefit from better understanding of why these things are important. I know you discuss it a lot, Nathan, but the training that some installers go on, it's these couple few day courses doesn't make you
Well,
meaningful install.
your auditor GTEC is the country's largest trainer that does the 3-day courses and gets paid from the government for the voucher scheme. And they probably got paid to audit this as well. So, like
Yeah, they're,
Tristan,
they're part of it. Yeah.
yeah,
Um.
like Tristan said though, it doesn't. Like, I don't want to upset anyone involved in this, but it doesn't take a rocket scientist to look at that data, especially with Valent, and think, right, there's a bit of a control issue here. They haven't been their controls haven't been set up right. There's some very large contractors involved in this. I mean, there's 19. I mean, I know some of them. I know some of the people that work for these. I mean, I don't know whether I should mention them or not, but one of the large contractors who I know very well, I know people working there, they installed 46. Their average SPF was 2.55. That's not good enough. Most of them were under 2.8. That's not good enough. Now, it's very easy for me to say that and be dismissive. All it would take is for someone like me or to go to one of their technical people and in a very sort of nice way, not sort of make them look stupid, but say, look, just make sure you get the controls right on this particular model. Now, and this is one of the thing, and I've because obviously, as you know, Energy System Catapult are going to be involved in the air-to-air trial. Now, arguably, I'm the biggest advocate of air-to-air in this country. I've been shouting about it for a long time. My family's put air-to-air systems into the studios of some of the most famous people on this planet for half a century. And what I said to Energy System Catapult is, can you publish on an open space, i.e. social media, your design methodology? So like we can be peer assessed and we can all put input and say, oh, you maybe should do this or do that. So that the design methodology is sort of tweaked before the actual study. Because if that would have happened with this project, people like myself or lots of other people could have said that, you've got Warmworks, you've got Eon and OVO involved. When they get their contractors, just have a little bit of a meeting with them and say, this is how you're going to be using Dakins, you're going to be using Valents, you're going to be Mitsu's. There's only 3 manufacturers. Obviously, you had Kenza with their grandson. 3. This is what needs to happen with the control. Da, 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 da. And you could have really mitigated all this problem because a lot of the reasons these are underperforming is just something simple. It really is something simple. It's control. And it wasn't picked up on the audit process because I've spoke to people that were involved in that audit process, which arguably it should have been, because it is relatively simple. The data tells us exactly. I mean, obviously Tristan's spent lots and lots of time unpaid going through all this data, and you can kind of see from the data how these systems are being controlled. I don't want to push back against you, Katrina. It's not your fault.
No, do go for it. That's why we're here, right? So one of the things, so yeah, the controls are an issue. I'd also like to raise the issues around the design stage of the systems itself. And one of the findings, which was interesting, was that there was little correlation between the design scope and the realized SPF. Now that's not good. That's Yeah, it's not good. And there's a few reasons for that, but I think that's one of the lessons learned is that design of the system really needs to be better. And that's part of that is tools used for the design. So that there's like using the default U values for things. They're conservative. You're going to oversize the system, which we know isn't good. But a big part of it as well is the participant behavior. It's people running it not the most efficient. It's
Yeah,
lowering the setback temperature. It's raising
yeah,
the hot water demand just because they want to raise the heating quicker than it is. There was a preference for towel rails in bathrooms, which we know isn't the most efficient emitter. It's so consumer design is consumer preferences. It's also a big factor for it, and that's going to be a big factor for the rollout of heat pumps.
massive.
And we can sit here, and debate all the intricacies of the efficiencies, but like as you say, no one's going to care about that. We're not going to win the argument on heat pumps by getting people to care about their COPs. It's are they warm? Can they afford their bills? That those are the things we wanted to learn and to focus on. And the things that we have learned and it's like some of the barriers we learned in the project have now changed because of it. So one of the frustrations in the project was how long it took for the DNO to get
Mhm.
through to the when you need to do the apply to connect if your heat pump was over a certain load size. That was taking months for some for them to do the local calculations. And so we had good engagement with the DNOs and the ENA, the Energy Networks Association, came back basically during the project, and they've streamlined their processes and digitalized some processes to make it much faster to that connect. Because we were losing some participants. They're like, now it's taking too long. We don't
Mm.
want to wait that long. And so they were just dropping out of the program. So that was really, really good. The second one, which was also a barrier, was the permitted development rights. So we
Yeah.
had some issues, particularly in Newcastle, on the more terraced streets in the urban areas. The 1 meter boundary rule and the noise rules and the sizing of them caused some issues to recruitment. So there was some, yeah, it was too close to the next door property. And then on the noise limits, we couldn't add as much mitigation of the noise because of the size limits. So those have now, we're expecting them to be changed in the spring. So the learnings from this project help to realize what you can change the development rights to make it much easier to roll them out. Because we know it's kind of the outcome we want. We don't want noisy streets full of that. But
Yeah.
if you can make them slightly bigger and make them mitigation against the noise, then you're gonna fight that. Um, so there's things
I mean,
other
that's
things
great.
we learned.
That's so obviously people like myself and obviously Tristan, we can go on and on about performance, but yeah, there's some great other bits and pieces of data. Like, so you just mentioned this, or like the DNO. I mean, our energy systems catapult, because obviously there would have been some DNOs better than others to work with, and others that were probably dragging their feet a bit. And I'm presuming Energy Systems Catapult can't sort of name them in their report, but were you able to sort of like say to some DNOs, for instance, well, we're finding these DNOs have this process and this works for them. It might be something that will help you. I mean, were you able to sort of nudge some of them and some of the sort of local authorities as well, I suppose, who were dragging their feet with planning or permit? Were you able to sort of look at some others and think, oh, well, they're doing it quite well, and that's because of this, 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 and this, and then because I suppose you can't put that in a report, can you? Because it's too sensitive in it to sort of have a go at.
I mean that is what one of the issues is, that inconsistency in
Yeah,
approaches across the DNOs and across local authorities in terms of what they require for planning permission and the development rights. So some will require a separate noise assessment, like from even if you've met certain conditions. And the DNOs, some required kind of bulk applications if you're doing big area, and some are doing one by one, and there were different approaches even within the DNOs in some cases. So yeah, there was, and they were really engaged. We had good discussions with them and how we can improve the system, because they don't want to be a blocker for this.
yeah.
They're a big part of this journey is the DNOs. So the lessons learned for them were really valuable from the project.
I was going to say, so I mean, have you, as an organisation, been able to sort of bring these DNOs together in a forum space or whatever, webinars, and just tell them your findings and what you thought could work for them all? Or is that something you are going to do, or have you done
Yeah, I don't know if we've done that specifically since the end of the project, but it was throughout the project, and the ENA, they
it?
do that
Yeah,
themselves as well
yeah,
internally. So they're constantly discussing how, because the ENAs are very conscious. This is a going to be a big part of their future is the electricity demand in their areas from heat pumps, from EVs and growing. So they're keen to be on board and engaged and like to learn where they can on what's coming and how they can make it
yeah.
a better transition.
Because it's a big learning piece for them as well. I mean, they want to learn. Everyone wants to learn. And now I'm going to say something here, Katrina. I hope it doesn't embarrass you, because obviously I have been pushing back a little bit, but I want people to realise I'm pushing back against Energy Systems Capital, not you. And so I'm going to describe people when I first met you. So I first met you at Kenza, at a Kenza VIP event. It was actually at Octopus's HQ, wasn't it?
Yeah.
It was a Kenza evening thing, VIP thing, and I got introduced to you. And like I normally do, waffling on about something. I think it was about local authorities or something. And you pulled me up and you pushed back. And you said, Nathan, I think you're wrong. And you were right. I was wrong. And you were good for doing that because obviously I'm a father of a daughter. She's 12. I'm an uncle to a niece. And I would hope as they grow into older women, they will have that confidence to do that as well. So I want my listeners to know that because I don't want them to think, oh, Nathan's pushing back on Katrina loads and loads and loads. Because I'm not. I mean, it's a very, very good. I think there's some real positive stuff. Obviously, I know Matthew Haylock really, really well, who's obviously a big part of this project. Um, and he's a big, big supporter of my podcast. He listens to all the episodes. And Tristan, you've obviously found it very, very, very useful, isn't it? I mean, obviously, there's some things we're going to learn. Yeah, it's for me, it's just some simple things because before this project started, I have said this to Matthew, I knew the variable that would be the most important variable. And I'm not just saying other people would have known, because whenever these studies have took place, where it's the energy saving trust ones of 2009, 2011, and the other ones, understandably, there's this assumption that right, we need some people to put this stuff in, so we get MCS contractors to do that. But that's where you fall down right from the word go, because MCS does not mean you're competent, and it's not actually MCS's fault. And I've been pushing back against this a little bit because MCS get blamed all the time for poor quality installs. MCS have to rely on our training and qualification industry, and if our training and qualification industry is just training people for 3 days, giving them a qualification, because obviously legally MCS can only put on their register people that have had a qualification. So arguably, it's not their fault. And understandably, when all these trials take place, you naturally assume that everyone on that register is going to be okay, knows what they're doing. Uh, they don't, but that's not always the engineer's fault, because the problem with heat pumps, obviously, heat pumps are great, great technology, but their greatness is also their weakness. It's because of this huge range of variability in performance. If I was to put a boiler system in crap, I'll probably get 75% efficiency. If I was to put it in really, really good, 95. That's a very narrow range. If someone puts a heat pump system in crap, 200% efficiency, or they could put it in well, 500. That's a massive, massive range. So it's about helping people understand how you get closer to the ranges we want. They ain't got to be putting them in at the higher ends, but to just get over that little where they should be. And usually it's just a little bit of knowledge they just need to know. So obviously with the valence, obviously we picked up, they probably just don't know how to. I think a lot of them were on probably fixed temp on the setting rather than weather comp. I mean, interestingly, Tristan, I don't know if you noticed this, Mitzi's came out as the highest, just slightly. I think that I mean, Dakin's came out the lowest. Not that that's relevant because it's down to installation, but I think Dakin's came out the lowest. Then it was surveillance. Then was Mitzi. Have I got that right?
Fractionally higher, yeah.
Mitzi are probably jumping up and down there, going "Ray" in their offices.
I was
Bladed will probably be on the phone.
Maybe it's worth saying, like, obviously we talk a lot about efficiency, but that is motivated by a concern for running costs. So it's like, when we see efficiencies of 2.8 or lower, you sort of worry that household is paying more than they should be on their running costs. And so it's not just that we're interested in that performance in a kind of pushing it as high as we can. It is fundamentally just trying to, if we can get performance above 3.3, then we can deliver that kind of low cost of heat, can't we, for customers?
Which really
Obviously, it's
comes
not.
back,
Go on, Katrina.
which really comes back to that system design. Because as Nathan, as you were saying, you can whack in a crap gas boiler, and we've historically got used to fairly low gas prices. So people are used to it. They don't know how well their gas boiler's working. They've been warm, their bills, they're not great, but they've been what they are. Whereas you do that with a heat pump, and yeah, you are going to have really high bills. But that system design, that education of what that looks like, I think I don't know, I know Nathan, you spend a lot of time thinking about this, the training and everything. I was wondering if you had any thoughts about how, because as you said, the UK is one of the biggest markets for air-to-air heat pumps, like on the commercial side, of how we get people into installing on the commercial side interested in installing on the domestic front with the air-to-air.
Probably won't happen. They don't want to do it. Why don't they want to do it? Let's be honest, because customers are hard. it's hard work going into people's homes. You know, we live in this lovely, diverse, heterogeneous society. That's fantastic, but it is very hard because whereas in the commercial environment, you don't do that. You're meeting the same facility manager every time. So let's say you got 20 clients, you're meeting the same people that you deal with every time. You're not walking into people's home where you don't know them, you don't know how they're going to interact with you. And because when you walk into someone's home, the first thing that's happening is they're looking at you instantly. Lots of heuristics are going on, lots of subconscious stuff going on. Can I trust this person? So obviously, if I walk into a home, I'm short, I'm unfortunately a bit overweight at the moment. I've got an Essex accent, so I know people are going to judge me on that. That's natural things to do. We have these what they call can't think what it's called, confirmation biases and stuff like that. That's just natural human. And then I've got to build up a rapport. People in the commercial sector haven't really got to do that. There's over 50,000 F-gas engineers. I don't think most of them will want to, unless they see a value in it, like sort of monetary wise. Some of them might think, oh, yeah, well, I used to be a tradesperson back in the day in domestic. But yeah, if I take my cousin, there's absolutely no interest in my cousin or his engineers to work in the domestic sector at all. So, and actually, if I'm honest, a lot of the air-to-air engineers will actually say, we don't know nothing about hydronics. They'll hold their hands up. My cousin does. He doesn't know anything about hydronics and sort of wet heating systems. So yeah, we have got a kind of we're relying on the sort of the gas engineers uh, wanting to get excited about this and transition, which is sort of where I sort of fit in and try and help because a lot of the gas engineers don't actually need to go on these training courses yet. They just need to understand some very fundamental. So one of the biggest problems I see with super duper gas engineers, you can fix any boiler going. They just don't understand why radiators don't need hot water. And simple things. The temperature outside is constantly changing. It's a dynamic thing, and that means your temperatures in your radiators only have to be, you know, -3 outside. Yeah, it might need 70 degrees in it. If it's 9 degrees outside, you've now half the heat loss at the home. You need to push half that heat into the home, and you can do that with less than 50. And it's simple things like that that they've never been taught. You could be critical of I can be critical of the industry. Why they've been taught how to safely install gas appliances, which is which is very, very useful. Let's face it. But so some of them aren't. But some of them now are really, really grasping this, and this is why you're seeing this transition. Because some of them I know that have transitioned, love the fact that they're now being seen as engineers. This is a science to this. It's not just about plonking the boiler on the walls. There's a bit of a science. So it will be the gas engineers mainly that we will have to transition, and I think that's doable and possible, not with the paradigm we're at the moment. Because the paradigm we're at the moment is training centres making lots of bloody money, especially at this voucher scheme, for having someone stand at the front, go, "Want blah 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 blah" for 3 days, and expect everyone to remember it, and then go out and be competent. That's not how learning works. Never has worked like that. But we're getting there. I'm still positive. We are getting there.
I think,
Yeah,
and
and
that
it's very
is such an but the value if gas if gas boiler engineers in people's houses, if they were advocates of heat pumps, that makes such a difference.
Yeah.
So I, as you've identified, I'm a woman, live by myself, and so whenever I get an engineer come in to service my boiler,
Yeah.
it's always a man. I always ask them, like just out of kind of curiosity, to get their opinion on what do you think of heat pumps or and like anything. And the answer is always, well, it has been the last few years, either don't worry, love, you're going to get hydrogen, or nah, heat pumps don't work.
Yeah.
And there's a strange man in my kitchen servicing my boiler. I'm not going to antagonize him too much,
Yeah.
but that's if he were instead to say, "Now, yeah, your heat pumps, they're the thing. They're like efficient, they're warm, low carbon, they're coming." That would make such a difference.
Yep. No, exactly that. It's such a really good point there. And that's my industry at fault, that is. So that's the manufacturers, it's the merchants, it's the high echelons who haven't got a good clue about thermodynamics. If I'm honest, that's people like the HHICs, people like Beamer, because I'm critical of them as well. It would be quite easy if we really think about it to disseminate to these engineers, look, this is these things do work. They've been working in buildings way before we had natural gas boilers, and unfortunately that's not happened. And like you pointed out right at the beginning, one of the reasons is because They're trying to push a technology that they still want. They still want a gas network, which means they want hydrogen, which is they
Which is
push.
understandable, right?
Yeah, of course it's
This is
yeah, of
their
course.
livelihoods, and if it's the generational, it's what they've known. And hydrogen would mean they could largely stay in the same industry in the same
Yeah,
way.
definitely understand. And also, what people don't realise is, our engineers who built that gas network, we built one of the best gas networks in the whole of Europe. Us and the Netherlands arguably have the best gas network in Europe, which meant that we could all have these gas appliances and run them cheaply. Other countries couldn't do that. Scandinavia couldn't do that. They're the largest archipelagos on the planet. You can't run loads of gas pipes up to people's individual homes because you're going underwater. Can't do it. What you can do is ship kerosene, heating oil across on a boat, which is why they went oil boilers. They became the lead. Sweden became leader in oil boilers in Europe. But yeah, so we that industry has some really good things to sort of shout about, and unfortunately, not all of them in it have gone a bit too far down this hydrogen thing. But yeah,
Could I,
yeah, go on, Tristan.
I just thought it'd be worth making, the point that, we do like, I mean, it's a point that you make a lot on the podcast is there are some really great engineers out there, and it's been fantastic to work with them at Heat per Monitor. Um, you know, um, Companies like Custom Renewables, LibTech, um, Adam and Heat Geek and Simon, Urban Plumbers, fantastic. Damon, it's been really great seeing the work that those guys are doing, and they are delivering consistently good high performance systems and low running costs for customers. Um, and like you've always said, uh, Nathan, we need to listen to what they have to say more in the industry. And
Yeah,
maybe,
and consumers though, because people like yourself and people like Katrina, if you look at that adoption curve, we're still at the innovator stage. We're not even at early majority stage. And I know for a fact there's innovators out there, like yourself, Tristan. You've got a heat pump in your own home, who know way more about the science and heat than 90% of the technical directors I know in this industry. And I'm not joking. I'm not joking. That and I'm going to be doing a talk about that to sort of the market departments of the man, because there's a lot of manufacturers in this country. 650 brands are at the last installer show. 650. I come to watch you at a show speak, actually, Katrina. What was that installed, or was that where were you speaking when I come and watched? Was that Future
Is that
Homes or?
future build?
I mean, there's so many bloody shows now. I mean, that's another problem. I think there's so many shows now. I mean, but yeah, you've got market departments and you've got technical directors even that just don't understand the science of heat and argue. Well, I am going to be arguing that they should do, because we've now got a stage where homeowners and people like yourself that are working in this industry. I mean, I know Madeline. If I gave Madeline, if I said to Madeline, right, how much heat does a home need if it's 12 degrees outside? The heat loss is like 10 kilowatts, which is my three. She'll know. I'm just punch it into a calculator, but she'll be able to tell me. And like I say, I know probably 95% of technical directors wouldn't even, they'll think I'm talking Klingon. They'll be, what are you on about, Nate? Do you know what I mean? That's the problem. That is a big problem. We've got most of my industry does not know anything. And I always use this, and I, I've probably embarrassed too many people sometimes with it, but I've asked people, what is a what? And there's consultancies in this industry that are getting millions from the government. And I've said to them, what is a what? And they don't know. They don't know it's a joule of heat per second. I said, look, you're considered the experts by our government. And their excuse was, yeah, but we're not engineers, Nate. We don't know. We've got our own things. We don't know how to go and fix boilers. I said, you haven't got to know how to fix boilers and put heating systems in, but you should know what a what is if you're in this discourse talking about energy. You should know that the joule is the SI unit for energy, and you should know what is. Because especially these people that keep advocating insulation is the number one thing you got to do to reduce energy bill. No, it's not. It's a
Well,
great measure for a lot in a lot of cases, but no, it's not. And E3G have just written a report basically saying insulation is the number one thing to do. No, it's not. You're going
that's
against the laws of
something.
thermodynamics, and that's the trouble.
Yeah, I just wanted to pick up on that point, something from the project that, so as I think one who said before, most of the houses in the trial had radiator upgrades.
Yeah,
Not all of them, but most did, just because needed larger surface areas for the lower temperatures. We did no deep retrofit of it. So
yeah,
we had these were installed in properties, I mean, it's all in the reports, but from a whole range of EPCs, we had EPC E with no retrofit. We had, I think 15% had some insulation measures, mostly loft insulation. Um, the Yeah, we weren't doing big fabric upgrades first. It was yeah, heat loss.
Yeah, yeah, yeah. And this is another problem. So the largest trainer, retrofit trainer in this country, we talked about COVID. I was in a meeting with them, in massive meeting, about 60, 70 people involved in it, COVID. And, I've seen their training material and, because they did ask me to look at it. And they didn't know enough about heat pumps because they trained the retrofit assessors and coordinators about that stuff. But in that meeting, uh, largest trainer in the UK, I noticed they had a heat pump behind their head in the office. I said, "Oh, look, you got a heat pump." And they turned around and said, "That's not a heat pump, Nathan." I'm like, "It is." My fellow put about 10,000 of them things in. And now, respect to them, they did get back to me about 3 weeks later and said, "Oh, yeah, that is a heat pump. We didn't know." And this is the problem. That's the highest person in the UK involved in training around this stuff. And I see this all the time now because this retrofit piece is massive. There's think tanks and charities and all these different sorts of entities involved in this discourse. And I just wish some of them just sit down and just learn a few bits and pieces, learn what a watt is for a start. Before you start spouting out, you can't do this and you can do this because you can do a lot of stuff. And luckily, we've got people that are providing the evidence, which is what you guys have done. Uh, Katrina, great. Thank you ever so much for coming on. I hope I haven't pushed back too much. Uh, I mean, I'm known for that, so apologies. Trysten, thank you ever so much for coming on. Obviously, I've seen you've done a LinkedIn post. I mean, poor old guy knew he's going to probably be ringing me up tonight because I know Guy knew he's your CEO, isn't he?
Yeah,
And
indeed.
I organised his heat pump installation. Fantastic installation. What I did there actually, the person who put that in for him had never put a heat pump in ever. And what I wanted to do, I knew they were a great hydronics engineer. So what I thought, well, it's no good me just, I know lots of good engineers. I want to inspire someone to sort of get into the heat pump industry. So I gave them this opportunity. I said, look, I mean, they didn't know who Guy was. I said, look, this guy is very, he used to be the special advisor to two of our energy secretaries. Um, and I hooked him up with the manufacturer, and he's going great guns now. He's loving putting heat pumps in. So I wanted to inspire him as well as getting Guy a good install. So it can be done, and like Trysten's data is pulling out. There's these very very well established companies involved in this who aren't getting as good as the engineer that put Guys in. That was his first one, but that's all doable. That is workable. It's an education piece. Uh, it's it won't take a lot for people to sort of understand what little bits and pieces need to be done. I didn't know if any of you wanted to add anything, but I'm going to say now, thank you ever so much for coming on the show. But Trysten, did you want to add anything?
Yeah, just want to encourage anyone to have a look at that website. So eoh.heatpumpmonitor.org. Just yeah, it's really worth dive into the data, have a look at a few systems. I think there's stuff there for everyone in the industry, really, like to useful information, just in terms of the learning, the ongoing learning, and so on. Yeah.
Yeah, I'd say really the opportunity, the learnings from this project and the innovation that's possible and needed as part of this journey. It's otherwise, because I know we talk about your family, Nathan, and your history of working in this area, is that without this innovation and learning, we're going to end up with my future granddaughters installing the same problems as your grandfather, which is that's not how we're going to save the world, right?
Mm.
So this is why we're all here in the end.
Mm.
Um, and then a final plug is you mentioned the air-to-air heat pump trial. We're currently in recruitment for that, and I'm not sure when this podcast will go out. We'll still be in recruitment, so we can put a link in the show notes perhaps of people wanting to sign up to that.
Is that for customers? For
It's
home?
open to public. We're
Yeah, yeah.
recruiting people to air-to-air heat pumps. Yeah,
Oh, that's good. Yeah, we'll do that. If you grab, if one of your team gives me the link for that,
yeah, I'll do.
because going back to this project, crikey, I wish I'd have known about it soon because I'd have got my dad to have one of these installs, because it was free. Some people have some good. I mean, a lot of them. I mean, obviously, as we said, probably aren't as perform, but they can be. It will only be a few tweaks with some of them to get them performing quite well, and they've, yeah. Great little thing. No, I'll do that, Katrina. So thank you ever so much for coming on the show.
Oh, thanks for having me.
It's been a good one, and I'm sure we'll see each other all soon. Thank you very much, guys.